order. Okay. All right. So what we will cover is by looking. So these are called graph theoretical measures, and the idea in this one is that you can use ICA to find connectivity pattern, right? Or you can take a seed-based analysis from one region and correlate with all other regions. Here what is done is every region is taken and correlated with every other region, right? So, and this is done for all the regions. So can anyone explain what is the similarity between seed-based analysis and this one? So, hmm? Yeah.
So in seed-based, you have the coordinate and the radius. So it doesn't have the entire area.
Okay.
It's like a main center intensity point.
Okay.
The radius around it.
Okay.
This would be, I'm guessing, it would be using mass of the region.
Okay. Okay. So for seed-based, like taking the spherical wave was taking a sphere and the um, average time series is one of the way. I could just take one voxel and do correlation. That would be seed based, or I could take all the voxels in the region, average it, and then run it, right? So it's not confined to taking a sphere, right? So do you see any similarity with seed based and this one? Or so how is, maybe the way to ask is, how is this different from seed based? What is the similarity and what is the difference?
So we can say seed-based subset of this.
Okay, good. Tell me more specifically, what is seed based? This is a matrix. What would be the seed based analysis?
In case of seed-based, we have one region of reference and it is correlated.
Right. So in this matrix, that will be,
So the seed-based are stars more than one. So if I take one line, I mean one column or one
one.
row, that will be one seed-based analysis.
Very good. So seed based is um, so in this case, there are several regions from the seed based, right? And as Rahul said, if we were to take the left, like a voxel from the left motor cortex, then it would be this line, right? This is the left motor cortex with all these regions of um, vision, somatomotor, dorsal attention, and so on. So the seed-based analysis represent a single line of this correlation matrix or a single column. Okay, and so this you can think of um, in a different way. That is, this gives you more information about every region with every other region. So it tells you like a global connectivity pattern, if you will, right? So here we are not, it's not hypothesis driven. However, we can look at any specific region that we want, right? That is one way to think. The other way to think is that once we have all these measures, this is a different way to also look at brain connectivity, right? Because you can, uh, for, ex for example, you can see how different regions are connected, and then you can make a aggregate properties, right? So I had showed you this paper by Damien Fair about development, right? Young people, older people, and young people, some of the networks had connection, while in adults, most of these networks that he was showing were all connected. So if you were to um, infer what kind of correlation matrix you would see, how would it look like? Like in the first case, let's say in the adults, right? All, like there was connection between many different regions. So let's say it looked like this one, okay? Now, for young people yeah, like kids, there were many connections that were missing, right? So how would um, a connect
More white regions would be instead of blue or reds, we'll be having more of whites that will be zero.
right? So because the connection is weak, so it would be more in these regions, right? So there would be less number. Okay, so this is what we will quickly cover, right? So I had mounted, installed. So in the Atlas base, right, for this graph theoretical measure, these are based on atlases, right? And there are several different kinds of atlas. One is the automated anatomical labeling, AAL. The other one is Schaefer, which we have used here. And Schaefer has 400 regions of interest. There is also the Power Atlas. So they have already defined in the brain the locations, right? So maybe another, again, you can do ICA, but another way to think is that rather than do ICA, we can take the time series for each of these regions in the atlas, take the corresponding time series, and then correlate. And that may give us statistical properties, right? Remember, like when I was mentioning about movie watching, right? Um, if all of you watch the movie, there is going to many things which is similar, but maybe there are things which are not, the responses would be different based on each of you, right? Maybe you had watched that movie before, maybe you were not in a good mood to watch that movie, and so, you know, yeah, or many other factors, right? And so you take the time series and then you correlate everything, like in the movie watching, you correlate every region with other region from that same person. Um, in this case, we take every region time series and correlate with every other region. Okay, am I clear? Okay. One of the biggest disadvantage of this method is that, you know, you're taking a brain which has very high spatial resolution, like 3 millimeter by 3 millimeter, and dividing the brain into only 400 regions, right? So you're throwing away a lot of the spatial details, right? So that is like one disadvantage. Also, across different atlases, there are variation, right? There are, like, Eo Atlas is one, the Schaefer Atlas is another, Power Atlas is another, in the Sheehan Atlas, there is AL Atlas, and none of these atlases uh, exactly overlap. So there is some discrepancy between what is left motor according to these atlases, right? Or some specific region. So that is one source of variability that exists. Also, the other, what happened? What happened? Huh? Oh, the other thing that happens is, as I mentioned, that, you know, if it takes the left motor, you are averaging all the time series into one time series. So you're losing information which is within that left motor. And sometime, I would say actually, in many cases, what is inside that information, inside that location is the most important thing, right? It's very rare that you will find a disease which has affected that entire cortex, like entire region of these ROIs, right? So even if there is a stroke, the stroke, I mean, it would be um, quite like, it's very unlikely that the entire lesion, right, or stroke or whatever disease is going to affect the whole ROI, right? And if it doesn't affect the whole ROI and only affects half the ROI, then maybe the most important information may be there, that, you know, why is it that some voxels in that region has been affected but not others? By doing these kind of analysis, you're throwing that away. The other advantage I would say is that this is kind of an unbiased way of looking at connectivity, because yet, although it's a crude way, you're taking every, like, ROI time series and correlating. So it doesn't matter which region is affected more, which region is affected less. After you do that, you can find out. While in ICA, it may get affected, you know, if um, the region has like low activity versus high activity, where that principal component is going to be determined. With this one, it doesn't matter because it's a spatial map. You're averaging the spatial map, the time series, and then doing the analysis, right? So again, I had asked you to do this, so I'm just um, right. So we use the Schaefer Atlas, and these are the regions. And in this case, again, like you can also have Geo Atlas. You can also decide how many ROIs you want, right? Uh, and here you compute, and then you are looking at the correlation structure, right? The correlation matrix is identified, and then it generates this correlation matrix. So this one has Schaefer 100 ROI and displaying using the UO7 networks, right? So this way you can find how, like, between the different visual regions there is connection, how between, so you can see, right, this is the visual region, so this is more connected to itself, so this is more high, right? This one is also related, so so visual, somatomotor, dorsal attention, salience, ventral attention, limbic, default mode. Yeah, I don't think it is correct. It's, right. So what has happened is that, so I'm trying to figure out. I believe this is left, 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 and then it is right. And this is again right, right? Um, so that is why visual to visual looks okay. Here visual to visual looks okay. Um, I think for this purpose, it is, you can, if you have to run, just run this, and then I will let you know the exact order. Okay, so so for any data, you should be able to use this codes to generate this correlation matrix. So um, those of you who want to use autism data, you can load the data, and then if you want, you can use the ROIs from here, and then uh, do the atlas. Again, this is loading the autism data. And then abide, these are the pre-processed data. And then we extract the time series. So, um, so we can do, like, so far, all of you should be able to do ICA, all of you should be able to do seed-based, and all of you should be able to do graph theoretical measures. And based on that, you could use the autism data to think of a hypothesis, and then based on the hypothesis design, decide which analysis method to use, and then um, test those. If those of you who are thinking of ALFF or FALFF, let me know. Uh, One option is I could, if you know MATLAB, I can show you, I can give you the code, or else if there is AFNI, I can also show you how to do. So tomorrow, yeah, so maybe tomorrow morning I will have Pratik show you how to do this analysis using a GUI based analysis. But again, it would be good to know the different steps that you did. Also, it would be good to know what methods you would be testing. Any questions? All right, so anyone who has thought of the hypothesis, what they want to test? Yeah.
We're using ALFF values
Okay.
of DMNS to predict whether the person is autistic or has autistic traits or
Has anyone done ALFF
uh, I
in
saw
autism?
it was with deep learning and in that using a different approach to the model.
Okay. This thing is still running, so I can just. Hmm. Okay, so there are several papers. This is. Comparison of between ASD and TD showed that ALFF of the ACG and pre-CG were significantly increased. Okay, so they are saying, okay, so I guess you can try this one. They had only 27 autism subjects, so you have more, right? So, okay, um, you can do that. The One thing I would suggest is that it may be easier to do a voxel wise, right? Do ALFF for every voxel in the brain and then do a t-test and then see whether this region shows up. I think that is how they did. Let's see how they did. There is methods. Introduction. Okay. Oh, so they have used abide. Since all data were obtained from open access. Blah, blah, blah. Okay. What software did they use? So they use something called REST, right? So they have used REST. There is another software which exists called DPABI, right? So that is also fairly straightforward to use. But the biggest difficulty in using that software is that you have to organize the data in like very specific way, like the way we have organized the data here. So if you can do that, maybe it would be okay for you to do. Okay, all right. So can you write one paragraph of what you're planning to do and CC like your partner's name and email me? All right. Okay, that's good. So we should get results. Um, who is next?
So we saw this paper by Belmonte. His paper, he had a paper on autism and abnormal development of brain connectivity, where he said that in autism,
in Journal of Neuroscience.
Yes.
That's an old paper, like 20 years old.
But they do have recent citations.
Okay, okay, okay.
So only the theory that he gave that in autism there's hyperconnectivity
Right,
when it comes to physical local range connection.
right.
So we wanted to see in autism whether it's characterized by selective within network hyperconnectivity for social cognitive networks.
Okay.
So we took three networks, DMN,
Mm-hmm.
mentalizing, and we also took sensory motor
Okay.
for like a comparison.
Mm-hmm.
So does that characterize autism rather than a global brain connectivity? So we extracted time series for all those networks, and then we are doing refining unique correlations within those DMN. Like for example, 24 is there. So within those 24 connections, and then we are hoping to put it into a machine learning model which can give us accuracy based on 5 conditions we have: DMN only, mentalizing only, sensory motor only. All
Okay.
these three together, network connectivity only, or whole brain analysis. So
Okay.
which might have more accuracy in distinguishing.
Oh, you have extracted the data?
Yeah, we have extracted. We're working on machine learning.
Which model? Is what?
Like extraction of features is that the machine learning part is left. We've extracted the features.
Oh, okay. Okay.
Only the machine learning part.
Okay, which machine learning method are you planning to use?
So we can use SVM or random cluster or any other
Try, I would say start with SVM. It's so like it's very standard, right? And you know how to do SVM in MATLAB or how? Okay, all right. Okay,
And we did the correlation. We used your code for the correlation.
okay.
And then one more thing that I read in another paper that we thought we would use is that when it came to Pearson's correlation, they said that +1 to -1 would be a shorter range. So they use something called as a Z Fisher
Right.
to stretch that into +1.
Right. Yeah.
So we added that extra step.
I think that is good because for comparing across subject, they call it the Fisher transformation. Okay, very good. Okay, so tomorrow we should have results. Okay, all right. So two groups, 10 more. Who wants to go next? Oh, okay. Yeah. Okay. Okay.
For the seed-based one, I have a hypothesis-driven question. I have used the abide dataset for it.
Mm-hmm.
So I have taken 20 autistic population and 20 healthy control.
Okay.
And I have focused on 4 seed from the MDMS atlas, which are 20 to 5, 33, and 14, which are dorsal ACC, front DMN, dorsal PCC, and basal ganglia. I have chosen this because these regions are associated with mentalizing in cognitive control and adaptation of the cognitive control, and also with conflict monitoring, switching of internal external attention in autism, and they usually show hypo and hyperactivity in autistic population compared to the healthy control. So I'm doing a seed-based analysis, taking these 4 seeds, and I'm seeing the coordination with the other regions for both the groups. So I'm doing a resting state functional connectivity for the autism group, for the control group, and then I'm doing a grouping and comparing them using these statistics, which will generate key maps using the FDR connection of the key map to get the significant clusters, for which I have kept the cluster set of 20 and alpha value 0.05. So this is what I'm doing for the hypothesis driven seed-based analysis. And because I wanted to learn the ICM, I have used my own raw data that I collected here at CCS. So I have Parkinson's patients data for 25 patients. I cannot do for all those. Okay. So I have taken one rigidity dominant patient and one German dominant patient. I have done motion correction for both of them, and then I have done PCA because I saw components and ICA with the same number of components. Mm-hmm. Spectral analysis and compare the spectral PSD for the rigidity and tremor dominant, and then I have seen the correlation with the Yo atlas and the ICA components, and have compared which ICA component has highest correlation with which Yo network for both the patient, and have tried to derive something, and I know that it's not possible to say anything about subtypes with specific Parkinson's congress, but I just wanted to see if I do it this way, what I would get and what it would possibly do. So that's exploratory analysis. Okay, I think that is too much. I mean, again, if you have any questions about, you have to decide which one, like autism or Parkinson's. You just choose one. That is one thing. Also, like both you and your partner should be working together, and let me know like who is doing like what. And I would say like help each other to get it done. I'm happy to take a look at both your results, but focus on one for Friday. Okay. Okay. And okay, good. Anyone else? Okay, you are presenting on Friday, so if you don't say, there's nothing we can do. Okay.
So we are trying to explore explore the functional connectivity within the autism group based on the level of severity of the autism. So one of the factors that one of the phenotypical traits that we have is ADI in class 2 of the
Right.
test. So we are trying to explore, depending on the level of severity, if the functional connectivity is
Mm-hmm.
while comparing it with the healthy control connectivity.
Okay.
So
So how? Okay. So I have. Okay, I understand. So what will you do? How many subjects will you take?
sir, currently how much with just this general idea, the research aim is to find out and just to finalize one.
So okay. So how will you go about addressing this? So you have autism data,
So
and
about 50
right. Mm-hmm.
we will be processing using the pipeline, dividing the data, stratifying the data based on the level of severity of autism,
Mm-hmm.
and then the group-wise functional connectivity will be located for each of the severity. So
Will it,
mild, moderate, severe, there are three of the severity levels. Mild, moderate, and severe based on ADOS. That's the severity of the symptoms. Now, based on this stratification, we find and then three connectivity methods coming from the severities and one from the healthy control, and then comparing them using a t-test.
when you say functional connect, this one you're
Yes,
talking. So you're not using ICA. You are using
ROI based.
ROI. Okay, pairwise correlation. Okay, and then what will you do?
Then the difference, the finding out the difference between the groups. Basically, so using a t-test.
T-test between
the severities as well as with the healthy controls. So mild severity of autism compared with the moderate and the severe ones,
mm-hmm.
along with the healthy controls, that how much it is different. And specifically in the my specific interest is on the default mode network.
Okay.
How default mode network is being different in the level of severity as well as the controls.
Okay. Why not start with first find differences between autistic and healthy control, and once you find the difference, then focus on those regions? Or do you think it would overlap? Yeah. Right, right. Yeah. Okay, so that's what you're thinking. Okay, all right. Okay, that sounds good. And how far are you in? Okay, okay. Okay, who is next? Maybe you might as well say. Who is your partner? Okay. So can you say what you are planning to do?
Functional connectivity, but based on the FIQ score and which network is giving the significant result in the autistic and ethical or even within the autistic subjects.
Okay. What have you done so far?
Network, as of now, I've identified yet score base.
Are you using graph theoretical, right? Or are you doing ICA? Okay. Okay.
I'm trying to use three different practices, the AL, shaper, and power.
Right, that's good. Okay. Who is next? What? You don't have a partner? Why are you telling now?
No, so I'm not registered.
Oh, okay. Okay. Uh, maybe Sanchita, did you guys decide what the project would be? Huh? Okay. Mm-hmm. Mm-hmm. Salience network. Okay. Okay. Mm. How would you go about analyzing this? Mm, okay, you can use ICA, but if you want to focus on salience network, you might as well take the coordinates of the salience network, use it as a seed, and then see what you get. Um, okay, um, that is fine. So if you're going to focus on just one network, the other thing that you can do is not take a ROI, but take all the voxels and do the analysis. Oh, either one, right? You could use something like this one, right? So this one is like using the analysis with after FDR correction with 100 ROI um, between healthy and autism. Who else? Who's your partner? No. Yeah. Oh, Joshua. Okay. Uh, how about you? Mhm. So say that again. You're getting data. So they listen to music. Okay. Okay. Have you downloaded the data? How many have you downloaded so far? When did you start downloading? I don't know the download speed here, so when did you start? Okay. Tomorrow would be too, I think like you have to decide today, right? Tomorrow would be too late. Can, like if you, so 40 subjects you said? How, um, 40 subjects would take how much time? Like 2 hours? Okay.
Depends on like which files she's downloading, who's just downloading the resting and the PSP.
Yeah. Okay.
I think their dataset covers all the functions.
Right. Um, okay. Okay, and CC your partner also, right? Unless you decided to go your own separate ways. Okay. All right. Who is, yeah, yeah.
I'm thinking to like what are the different patterns between the given PhD participants and PhD participants.
Okay, right. Um, yeah, take,
Parameters will be low frequency fluctuations.
okay,
There is another parameter which is fractional low frequency.
right, right.
So these are the parameters we will see how
Okay,
they are varying between male and female.
okay. Are you a master student or a PhD student? Here, here.
Hmm.
Okay, where?
So
Oh, Jodhpur, right, right. Okay, yeah. I don't know, I forgot. Uh, you can try, but can I say that? So currently we have a grant to do that, and it's we have tried so hard to find gender differences, and there is only one or two areas where we find differences, and this is after like processing and pre-processing and trying every little thing. Um, so do you want to try that, or do you want to because it's very unlikely we'll see anything, because like the, again, I'm not saying it's not there, but the number of sample is small, and you can look. So there is, if you do gender differences and autism, you will find a few papers, not many, few paper. There's many editorials which has been written, but it doesn't have much results. So there is one paper by Xindi, and then there is another paper. The author is Adriana Di Martino. I can give the like just take a look, but if you can find out, I will say, can you please come and do PhD with with me? But anyway, if you can, if you can try, but I'm just saying it's very difficult. No. All right. What happened? I mean, if anyone can find gender-related differences, I have an open PhD position, like open to look at exactly that problem, right? And we have worked so hard to look at these differences, but we simply cannot find. So if someone can find in a week's time, I, I will give you, I will even pay for your airfare ticket. Okay. It's okay. I didn't know I was being recorded. Okay. All right. Who is next? Everyone else? No. The corner. Yeah. I can't hear you. Okay. Okay. One is dynamic connectivity, and the other one is differences in compared to hmm, entropy just in the default mode or whole brain or what? And you will link it to entropy? Have you worked with entropy? Have you worked with entropy before? Okay. Could you like explain what is that you're like, what aspect of entropy are you interested? Hmm? Okay. Who is left? No. Yeah. You're not registered. Maybe the two of you can pair up. It's okay. How about you? Yeah. What is your topic? Okay, tell me what you have figured out so far. Okay, like 15 minutes? I don't know what else to say. Do you have some ideas?
So
Anyone else left? Yeah.
I have a question.
Yeah.
So when we're doing systems and doing that, physical connectivity between the regions.
Right.
Between regions, I'm assuming that it's physical connectivity. If you want to test the computation connectivity,
Mm-hmm.
how do we go on?
You mean functional connect? So what we are doing is functional connectivity. What do you mean by physical connectivity?
So like how the information flows from one.
Oh, that's
Not a question for best extent.
mm, right. I mean, so fMRI resolution is like 2 seconds, right? So it's hard to say we can measure the information flow. People are doing it, but though they make a lot of assumptions, right? Um, yeah. Okay. Who? Who? Anyone left? Okay. All right. So since we have time, maybe I will just cover some, like, do you, okay, we can do two things. One is I can cover some more material, or else I will just wait here and make sure that every single one of you send me an email and have started their project before you leave the room. Which one would you prefer? Hmm? First one is give another lecture. So you want to work on your projects. Yeah, right? Okay. Stop.